Welcome to True Projects. In this video, we are going to explain about the project, which is an efficient and secure data sharing scheme for edge-enabled IoT. So before getting into the execution, first let's understand what is the project about. Let's say you are in a smart city where all the traffic lights, waste management systems, and healthcare services are connected through the Internet of Things, which are nothing but IoT. So this connectivity can greatly enhance user experiences and also the operational efficiency. However, despite all these advantages, there are significant challenges that prevent effective data sharing among these devices. For instance, concerns about security, privacy, and trust often lead to data silos where valuable information remains isolated and inaccessible. Moreover, in IoT devices, they typically have limited storage and also processing capabilities, which means that they often have to rely on cloud computing for data storage and analysis. This reliance can lead to network congestion, slowing down the data transmission, and ultimately diminishing the quality of experience for users. For example, if multiple devices they try to send data to cloud simultaneously, it can cause delays and inefficiencies in real-time applications like traffic management. So to tackle all these issues, in this project we are proposing a technology called blockchain technology. So here we are introducing a blockchain technology where the IoT data will be securely stored in the cloud. So what is this blockchain? So let's think about a traditional ledger like once used in accounting where transactions are recorded in a book. Now imagine that instead of one person keeping this book, everyone involved in a network has their own copy of it. So this is the basic idea behind this blockchain. So blockchain, it is a distributed digital ledger technology that allows multiple computers to record the transaction simultaneously. What's really cool about the blockchain is that once transaction is added, it cannot be changed or deleted, which ensures a high level of integrity and trust. Each transaction it is bundled into a block, which is nothing but grouping into a block. So these blocks they are linked together in a chronological order, creating a chain. And each block is secured by using a hash technique. So this hash acts as a digital fingerprint where nobody can alter it. So this structure means that everyone in the network can see the entire history of transactions, which promotes transparency. One of the standout features in the blockchain is decentralization. This means that there is no single point of control or failure, eliminating the need for a central authority. In blockchain, each participant has equal authority. Additionally, because of the way blockchain is designed, it offers enhanced security through cryptographic techniques, which makes it very difficult for anyone to tamper with the information once it is recorded. So how this blockchain works in this project? Blockchain it enhances security and efficiency of the IoT data sharing by allowing only authorized devices to access or modify the data, thereby maintaining the integrity and reducing unauthorized access risks. Its decentralized nature fosters trust among IoT participants through transparent, immutable records while enabling direct peer to peer data sharing, minimizes reliance on centralized cloud services, elevating network congestion and incorporating privacy preserving techniques to protect sensitive information. And we have different types of blockchains. For example, Ethereum, Bitcoin, Stellar, Ripple, etc. In this project, we are using Ethereum blockchain, which supports smart contracts. And moreover, in this project, we are incorporating Ganache and MetaMask. Ganache is a user friendly application where we can monitor all the Ethereum activities. And coming to the MetaMask, in this MetaMask, we can see the ETH deductions after each transaction made in the blockchain. So, coming to the proposed system, in this project, we aim to improve both the efficiency and also security of the data transmission between the IoT devices and the cloud service. By leveraging its servers, in this project, we aim to reduce the data transfer time, ensuring quicker access and responsiveness. And the integration of blockchain technology guarantees the integrity of the data through tamper proof records. Moreover, in this project, we are incorporating AES technique. AES it is a symmetric encryption technique which is employed to securely store the data. It is a widely recognized standard for secure data encryption. Additionally, in this project, we are using local sensitive hashing, which is LSH, to facilitate efficient data sharing, data searching, allowing for quick retrieval of information without compromising the security. Moreover, in this project, we are incorporating certificate-less signature method for verifying the authenticity of IoT devices, ensuring that only legitimate devices can participate in the network. For secure key management, the project utilizes Shamir's secret sharing key, Shamir's secret sharing technique, which enhances the security by dividing the key into multiple parts that must be combined to access the original key. So this is all about the proposed system. Now let's discuss about the extension. So here we have integrated elliptic curve cryptography to enhance encryption efficiency. So this ECC offers strong security with smaller key sizes, which makes it ideal for IoT devices with limited resources. Additionally, we have implemented cache memory. So this cache memory accelerates local sensitive hashing search operations by storing frequently accessed data closer to where it is needed. So this combination improves the system's overall performance and scalability, ensuring it can handle increasing data volumes and user demands without compromising speed or security. So this is all about the theoretical concept of the project. Now let's discuss what are the requirements to this project. So to implement this project, we need some hardware requirements that are processor of i5 and above, RAM of 8 GB and above, and ROM of 25 GB and above. And coming to software requirements, we need Python ideally, Node.js, Visual Studio Community version, Ganache, MetaMask, which is the Chrome extension. And the backend languages which are used are Python, JavaScript, Solidity. And coming to the framework used is Django. And front-end languages used are HTML, CSS, JavaScript, and Bootstrap 4. So now let's execute the project. To execute, we need to open the code folder which contains source code files. So let's open the code folder. So these are the source code files in the code folder of a project. Let's understand each of them. How will they be used in this project? So this is the data sharing folder. Inside this folder, there are Python code files that are intended to be dynamically loaded into the project during runtime. And this is the app folder. This folder comprises of two subfolders, one is static folder, templates folder, and also some Python code files. So coming to static folder, it contains files related to CSS, JavaScript, and Bootstrap files. These files, they contribute to the visual and interactive aspects of the application. And coming to the templates folder, within this folder, we will find all the HTML pages used throughout the project. It includes pages like index.html, home.html, and more, representing various sections of the website. And coming to Python code files that will be executed during the runtime of the application, which supports the project's functionality. And this is the Solidity file, which consists of a Solidity code. It handles structures, functions, and events with modifiers for validation. And this is the manage.py file. It is a command line utility that comes with the Django, and it provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations, and more. And this is the run.bat file. Instead of executing the project through command line interface, we have created this Windows bat file. To execute this project, we have to host the blockchain server first. So open the Ganache. So here blockchain server is hosted. Now get back to the code folder and double click on this run.bat file to start to host the web application. So double click on that. Here manage.py file is compiled. Now Django framework will host the application locally at the default address, which is localhost and the port. Now copy this local link provided by the Django framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here at the end, type index.html and click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Django framework. So here we can see there are two different links. One is Cloud IoT user login link, and the other one is new user sign up here link. Before logging in as user, we need to sign up first. So click on new user sign up here link. Before that, I'll show you how many blocks we have in the blockchain. How many blocks we have in the Ganache. So click on blocks. Initially, we have 4 blocks. Now we will enter the details. I mean, we will do the transactions and then we will get back to the Ganesh and see how many blocks are created. So get back to the application. Here, let's sign up as two users. One will be Kumar and the other one will be Kiran. So give the username as Kumar, give his password, give his contact number, give his mail ID, give his address, and now click on submit. So here, if we observe, Kumar has successfully signed up and his details are successfully added to the blockchain. And here, if we observe, Kumar's details are stored in the block number 5. And if we open the Ganesh, here we can observe that block number 5 is created in which Kumar's details are stored. Now, if we open this block number 5, here we have block hash, transaction hash, and if we click on this transaction hash, we have sender address, to contract address, gas used, gas price, gas limit, and transaction data. So now get back to the application. Let us sign up as the other user. So give the username as Kiran, give his contact number, give his mail ID, select the address, give the address, click on submit. So Kiran's details are also successfully added to the blockchain and they are stored in the block number 6 and this is the block hash code. If we open the Ganesh, here we can observe that block number 6 is created in which Kiran's details are stored. And if we open this block number 6, here we have block hash, transaction hash, and click on transaction hash. Here we have sender address, contract address, gas used, gas price, gas limit, and transaction data. So for each block, we have date and time at when that particular block is stored. Now let's get back to the application. Now let's log in as IoT user. So click on that. Give the username as Kumar. So let's log in as Kumar. Give his password and now click on login. So user Kumar has logged in successfully. And here he will be able to upload the IoT file. He will be able to search the file and also he will be able to view all the graphs. So now let's see how much ETH we have in the MetaMask wallet. For that, open MetaMask, which is the Chrome extension. So here we have 99.916 ETH. Initially we had 100 and now it is deducted to 99.916 because we have made two transactions. That is, we have signed up as two users. So that is why it has reduced to 99.916. Now let's do some more transactions and see how much balance we will have in the MetaMask wallet. Get back to the application. Now let's upload the IoT file. So click on data owner file IoT upload link. And here we have choose file option. Click on that. Let's upload this cloud file. Click on open. So it is loaded. Now click on upload. So here successfully this file has been uploaded to the blockchain. So this is the uploaded related details. It is stored in the block number 7. And it is encrypted and also saved in blockchain. And if we open this Ganesh, we have block number 7, which is created in which file details are stored. Now get back to the application. Let's search for the data. So click on LSH data, user search. So before searching, let's see how the data is stored in our code folder. So open it. So this is the file which we have uploaded. So open that. Here, if you observe, it is stored in the encrypted format. So here, if you observe, you can see that cloud file is stored in the encrypted format, which was uploaded by the user Kumar. Now close this, get back to the application. And here, let's search for the keyword machine learning. Now click on submit. So here, if you observe, there are two files in which there is term called machine learning. One is cloud.txt, which was uploaded by the user Kumar, and AATXT, which was uploaded by some other user. And this is the LSH similarity. And here we can see a download file link. If we click on that, user will be able to download the file. So click on download file. So here you can observe that user will be able to download the file. Now let's log out and log in as Kiran. So click on Cloud IoT user login link, provide the username and the password, click on login. So user Kiran logged in successfully. Now Kiran will also search for the search for the files using keywords. So click on LSH data user search link. So here let us search for cloud IOV. Click on submit. So it is in two text documents. So in this way, users they can upload their files and also they can search using their keywords. Now let's click on propose efficiency graph. So here we have proposed an extension efficiency comparison graphs. This is the efficiency of signature and this is efficiency of encryption. Here if we observe among both the proposed and extension encryption techniques, extension encryption technique is taking less time, which is an orange line. Now let's click on extension efficiency graph. So click on that. So here we have proposed an extension search time comparison graph. So this blue color represents proposed search time and orange color represents extension cache time. Using cache when it is giving results, it is taking less time to search the file and give the results. And when we use proposed technique, it is taking more time to search and give the results. So this is all about the project. Now let's see Ganesh. In Ganesh, how many blocks have been stored. So open the Ganesh, click on blocks. So after executing all the steps, we have total block 16. 16 blocks we have in the Ganesh. It means that the data is stored in all these 16 blocks. Now get back to the application. Let's see how much ETH we have in the MetaMask wallet. For that, open MetaMask. So here we have 99.984 ETH in my MetaMask wallet after the recent transaction. So this is all about the project. In this way, data can be efficiently stored and also shared.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.